Well, now we are going to start doing chapter exercises on algebraic expressions. And then when I say chapter exercises, I'm talking about miscellaneous exercises that covers everything we did. They are consolidations or extensive exercises. Now, question A says, state whether the following numbers are rational or irrational. If you consider the number to be rational, provide an explanation of why it is rational. Now, one thing we learn is that all rational numbers are of the form A over B, okay? Where B is not equal to 0. So anything that can be written, actually, that can be written in the form A over B, okay, is a rational number. Now, like question 1 here, I was just going to tick this is rational because it is in the form A over B. This is a mixed fraction. A mixed fraction is a fraction, so it is also a rational number. 36 is a rational number because it can be written like over 1. It is a rational number. Square root of 6, no, because square root of 6 is not a rational number. You can see it is said, I would say it is said because, you know, if you do like square root of 6, there you get like, if you press SD there, you have like no recurring decimal numbers. Okay, maybe because the screen is too small, you don't really see that. I can give you another explanation. It's like square root of 6, the factors of 6 are 2 and 3. Okay, 2 times 3. So this can be broken into square root of 2 times square root of 3. So this is a product of two irrational numbers because 2 and 3 are prime numbers. Okay, and then the square root of prime numbers are always irrational. So irrational times irrational must be irrational. So this is not rational, it is irrational. And then square root of 36, square root of 36 just 6, and then 6 can be written as 6 over 1. Therefore, this is irrational. And then square root of 7, as we said, 7 is a prime number, and then prime numbers are considered to be are non-rational, they are irrational. Now, square root of 7 to the power of 2, I'll write it over here. Square root of 7 to the power of 2. Note that the power of 2 always cancels the square roots. So this is just equal to 7. And then 7 is like, can be written as 7 over 1. Therefore, this is a rational number. Now, and then 8 is 0.45 recurring. So this means like the decimal part continues endlessly in this order 45, 45, 45, and all recurring decimals can be written in the fractional form. So this is also irrational. And then we have like square root of 6 and the quota. We cannot decide yet, and we like just say if you like 6. 6 and the quota, okay, is a mixed fraction. We can mixed number. We can convert it into an improper fraction. The formula to do that is like A, B, C equals to what? A multiplied by C plus B all over C. So we will do 6, which is the quotient, multiplied by 4. So 6 multiplied by 4 plus 1 all over 4. And that makes 25 over 4. Then, because it is square rooted, so it's like square root of 25 over 4. This is like square root of 25 over square root of 4. And then this is 5 over 2. 5 over 2 is in the form A over B. So this is rational. And then cube root of 8, 8 can be written in terms of its prime factor as 2 to the power of 3. Okay. And then the cube roots here and the power of 3 can be simplified. And then the answer is just 2. And then 2 is a rational number. Okay. And then cube root of -8. Okay. So over here, people are usually tempted to say this is an irrational number, but it is rational. I'll prove it to you. You know, we have like cube roots of -8, and then this will be like -2 to the power of 3 cube root there, and then the cube roots cube root can cancel the power of 3. Okay, the indices here is not even. Okay, the index is odd, so -2, yes, this is going to be -2. So this will be -2, so this is still a rational number. And then square root of 225 plus 400, this is like 625, and then 625, square root of 625 is 25. So this is also a irrational number. So the only irrational numbers, I say 25 over here, this is 25, and 25 can be written as 25 over 1, which is the form A over B. And then consequently, this is also a irrational number. So the only irrational numbers we had here was question 4 and question 6. Thank you. Now question B says, without using a calculator and by showing all your workings, determine between which two integers the following irrational numbers lie. Okay, so we need to find two integers in between these irrational those numbers are irrational numbers. Okay, I need to find the integers on the left and right of each of those. Now I need to remind you that those integers must be consecutive integers. So for example, if the first integer is 1, the following will be 2. If on the left of square root of 55 is 1, then on the right of it must be 2. Okay, if it is 3 here, then the right of it will be 4. If on the left is 5, the right of it will be 6. So there must be consecutive integers. Now, for square root like this, how do I know? If I write here 55 first, I will look at to the closest square numbers, because this is a square root. Okay, I must find the closest square numbers on the left and right of 54. So the square numbers here must be the closest must be 49 on the left and 64 on the right, such that if I square root all of them like this, okay, obviously the symbol here is lesser than, and lesser than. There, this will be 7 lesser than square root of 54, square root of 8. So the closest square numbers are 7 and 8. Okay, so square root of 54 is in between 7 and 8. Now the next question says negative square root of 54. So over here, you see the negative sign here will just reverse this order. So this will be it's like if I put negative here, okay, this will be negative square root of 49. No. Negative square root of 64 lesser than negative square root of 54 lesser than negative square root of 49. So which will be negative 8 lesser than negative square root of 54 lesser than negative 7. Okay, remember on the negative side, the bigger the number, the smaller it is. Okay, so here it's negative 8 and negative 7. Now for question 3, we have over here the fourth root of 25. Now, how can I call those numbers? Okay, I need to find a number that is 3 power 4 on the left, another number on the right that is on power 4 of root 25. So those numbers are, I can see the numbers will be like 16, because I did say 16 because it is like 2 to the power 4, okay? If I take 2 to the power 4, it's 16. 16 is lesser than 25. And the next one must be 3 to the power 4, okay? 3 to the power 4. Now, when I fourth root all of them, so over here I didn't want, okay, if I fourth root them, okay, then you know that the fourth root will cancel with the power 4, okay? And then the numbers are just 2. And the integers will be 2 and 3. Thank you. Well, question says, write down 3 rational numbers between square root of 2 and square root of 10. Now, it is important to note that rational numbers are all these numbers of the form that can be written as A over B. Okay, this detail I can just put it. Okay, now square root of 2 is, if I work out square root of 2, I'll say square root of 2 will be equal to 1,41, etc. Okay, so square root of 2 is like 1,41 dot 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 dot, and then square root of 10 will be if I press SD there, 3.16 dot 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 dot. Okay, square root of 10, this is like 3.16, etc. Now, to answer this question, I need to write down three decimal, three rational numbers between these two. So I can take any numbers, okay, in a number line. Let's say this was a number line, okay, where square root of 2 is there and then square root of 10 is there. I can pick up any number here. I can take a number like 1.42, for instance, okay, because it's here. I can take a number like 2, okay, I can also take 3. Easy that way, okay. And then note that this is finished, this is not continuous. So I just take 1.42, 2, and then 3, and then I stop there. They're all rational numbers. Thank you. Well, the question says represent this on a number line. For the first two here, okay, let's just draw a number line here. I draw the number line. I place in the critical values here, which are -2 and 5. So let me place -2 and then 5. And then over there, it is said that -2 is lesser than or equal to x. Okay, so there I can put just a bold circle to say this limit is reached. And then over here they say it's lesser than 5, but now let's see here. X is an integer. Okay, integers, remember, integer is like one that doesn't include negative or fractions. Okay, it has wholes from like if from 4 the next number will be 5. Okay, but with real numbers, there are infinite number, so many numbers between 4 and 5, infinite numbers between 4 and 5. Okay, but this case for integers, after 4 it's already 5. Now in the number line, I will not write, okay, I will not write my 5 there. Let's say a 5 right, let's say 5 right here, and then 4 there. Now to draw the number line, I must just say, okay, my solution will be from there to 4 there. It will stop there by 4. It will not reach 5. Okay, and nothing between 4 and 5 because they're integers. Okay, integer. The symbol stands for integers. And then over here, the question says x lesser than 3, and x is a real number. So now let me draw my number line. I draw a number line here. And then the numbers, the critical value here is just 3. And then it is said x is lesser than 3, so it will take it will be this arrow goes from 3 it goes like this, and then the fact that it is said that it's lesser than, not lesser than or equal, okay, I must put an open circle over here. Okay, now question 3, I'm gonna draw my line also, draw my number line. That was question 1, 2, and now 3. And they said here the lowest, this means the lowest interval is 4, and then the upper is infinite. So the critical value here is just 4. I say 4 there, and then it goes from 4 to infinite. So my solution will be like this. On the number line, it goes like that to infinite. Okay. And then question 4 is like from -√5 to square root of 25. Now look at there also we have a round bracket. Okay, round bracket, this means this limit is not reached. So let me first draw the number line. I draw my line this way, and I place my critical values. -√5, and there we also have like square root of 25 is just 5. Okay, and then over here the roots, the interval is not reached. I'll put an open circle. There the interval is reached, so I'm gonna put my full circle there, bold circle, and then we can connect the two like this. Now we answer the question by using number line. Now let me recap. For question 1 especially, over here the set is Z, okay? The set of integers. Now integers doesn't take into account decimal or fractions. So if they say x is lesser than 5, meaning it's stopped by 4, okay? It cannot be 4.5 or 4 and the third and something like that. So that's why in the number line here, I will start from -2, and then I stop there by 4, inclusive, not 5, okay? So here it's a full circle. Let me make it so visible. Now, over here, it's a real number. So if the x is lesser than 3, it means it takes all the values that are lesser than 3 except 3 itself. Okay, over there, we have like a square bracket which indicates the lowest interval is included. Okay, so over here it's like a bold circle, okay, bold dots, a full circle like that, to mean that 4 is part of the interval, is inclusive, and infinites will never be included in any interval, just goes like that. Okay, same also in question 4. Thank you. Well, now the question says simplify the following. Okay, we need to simplify this. Okay, I'll call it the standard form is to do to multiply expanding to use the distributive law, but it's not always recommended when we have special cases. Okay, so now for special cases we have formulas for that. Now let's see. Question 1, for instance, we do have like 2x minus 3y times 3x plus 2y. Now let's see. Here someone may say, okay, here we will use difference of two squares because we have a minus and a plus there, but look carefully. It's a tricky question. This is 2x and then we have 2y. If you rearrange things here, it's going to be like 2x minus 3y and then 2y plus 3x. So these terms are not exactly the same. Look at 2x, look at there is 2x, and there it's 2y. They're not the same, they're not like terms. Difference of two squares must be of the form like a minus b, okay, and then a plus b. But the fact that we have y next to 2 here is not the same thing. If this is a, this can be anything. Okay, so we cannot apply difference of two squares here. Here we must multiply by we must expand. Okay, this is what we'll do. Let me erase this. We will do 2x times 2y, and then 2x times 3x, 3y times 2y, and then 3y times 3x, and this will be like 2x times 2y makes 4xy, 2x times 3x makes 6x squared, and then negative 3y times 2y makes negative 6y squared, and then negative 3y times 3x makes positive 9xy. And now, is there any like term here? The only like term that you have is this and that. Okay, so those are the ones we can combine, and this will make what? Let me write the answer is going to be like 6x squared minus okay, plus 13. Excuse me, there it's negative. It's negative. So that makes negative 5 xy minus 6y squared. Okay, so this was question 1, and now let's see question 2. Question 2 is here: x squared plus 1, x fourth plus 1, x squared minus 1. Maybe I should just erase this. Oh, I can just leave it. Excuse me. I'm gonna write it over here. Question 2 was x squared plus 1, x to the power of 4 plus 1, and then x squared minus 1. Now let's work this out. Okay, I will prefer to move x squared plus 1 next to each other. Okay, I'll say like this: x squared plus 1 times x squared minus 1 times x to the power of 4 plus 1. To move, I wanted to move these two next to each other for good reason. Why? Because I know this will form a product that will lead to a difference of two squares. Okay, the two here forms a product difference of two squares. Let me just, here it forms a difference of two squares. Okay, then over here, you know, the difference of two squares says like if you have like a minus b times a plus b, okay, this is equal to what? It's just a squared minus b squared, simple as that. Now this will make what? X squared to the power of 2, okay, minus 1 also to the power of 2. I'm working these two together like that. If I combine them, it makes it makes this. Okay, it's like this is like a. Okay, we have like a plus b and then a minus b there. So now a is like x squared and then b is like 1. Now I just x squared to the power of 2 and then 1 to the power of 2. Okay, and then this will be like x to the power of 4 minus 1 times x to the power of 4 plus 1. Now at times this product, I got it over here. Here we're showing how it works. Let me not put the equal sign so we don't get confused. I just work out this is that, and then multiply by that. Notice we have another difference of two squares here, a product that leads to a difference of two squares. So we do the same thing. So this will be equal to x to the power of 4 to the power of 2. Okay, and then minus 1 also to the power of 2. And then this makes what? X to the power of 8. X to the power of 8 minus 1. You see how simple it was to calculate this? We could extend by doing x squared times that, times that, times that, times that, and then that whole product with times again with this. It's going to be quite a lot of work to do. Okay, but the shortest way, I think the smarter way to solve this is like by applying the rules for special squares like we did over here. Okay. Next question will be question 3. This one. Move there. Question 3. Which is -3 open bracket 2x minus 5 to the power of 2. Now there is another special product. I know you can over here split it into -3 2x minus 5 times 2x minus 5, okay, and then extend, do this times that, this times that, this times that, and this times that, and then you times it again by -3. But I would prefer to use the special product, okay? We did say that when we have like a minus b to the power of 2, okay, this is equal to a squared minus 2ab plus b squared, okay, in this case. So I want to really expand it as I showed there. I will just say this is equal to -3 open bracket a squared. My a is, this is my a, and that's my b. So it's gonna be a squared. So I'll say let me use square bracket here. So I will have like a squared, okay, minus 2 times a times b, okay, plus b squared, and then we can close this, close the square bracket there. I can substitute. My a is 2x, my minus 2a, a is 2x, and then b is 5, not -5 here. We need to be careful. It is 5 because this minus is in the formula. This minus on the formula, so a is b is just 5 plus b squared, 5 squared there, and then this will be like -3 open bracket 2x makes 4x squared, okay, 2x to the power of 2, and that makes what, -10, nope, -20x, and then plus 25. Now if we times by -3 each term, this will make -12x squared, +60x, and then -75. So that's answer to question 3. Okay. Now let's see question 4. Question 4, we have this, okay. Question 4 is open bracket 9x squared plus 12xy plus 16y squared in the bracket like that times 3x minus 4y. Now, you know, over here, we can start timesing each term, you know, apply the distributive law here and then simplify. Okay, we could start by doing that, and then times also that, and then this times that, and then this times that, and then finally do this times that, and then that times that, and then once we finish, and then we can start tracking like terms to simplify and then to write the answer. But there is another, excuse me, the smarter way of solving this is try first to look at the terms. Okay, this is 9x squared, 12xy, 16y squared, and then this is 3x and then 4y. You look at this, 3x is like 9x, is like 3x squared is like 9x squared. 4y here is like 16, raised to the power of 2 is going to be 16y squared. As I was saying, like 3x here raised to the power of 2 will be 9x squared. Then it reminds me one of these special products, especially for the cube number. We say that it was okay. We said that a cubed minus b cubed, okay, equal to a minus b, okay, times a squared plus ab plus b squared. Okay, this is the difference of two cubes. Those formulas are useful from left to right as well as from right to left. Okay, so when I look at this product, I'm seeing this raised to the power of 2 is that, so a squared is that, and then this raised to the power of 2 is that. So I can just maybe rewrite it this way: 3x minus 4 times 9x squared plus 12xy plus 16y squared. This is basically this form, okay? Because I was saying this is like 3x raised to the power of 2 plus this is like 3x times 4, and then this is like 4y raised to the power of 2. And then if my a is 3x, my b is 4, you notice that's like a minus b, open bracket, a squared plus ab plus b squared. So this product can, in short, you can just say this is equal to 3x to the power of 3 minus 4 to the power of 3. That's all. Okay, if you extend, if you times all each term here, you end up to something which is going to be this, and then this will be equal to 3 to the power of 3 is 27 x cubed minus 64. So whatever you're going to do here, when you times, expand, and then simplify, you're going to get this as your final answer. If you're unsure, try it out and then see what you're going to get. Oh, okay, I think there were, yeah, there were y here. I missed to write y there. Yes, y here. So 64y cubed, because the y over there. Okay, so whatever you're going to do here, if you expand, you're going to get this as your answer. Okay, this is, I believe, the smart way of solving the problem. Now let's see question 5 for the says. So we have this in question 5. Okay. I'm gonna write the question over here. Excuse me. Question 5 says 2 over 3x multiplied by 6x minus y minus 3 over 2 x multiplied by 4x minus 4 over 9. No, 4 over 9y, close bracket. Now, let's solve this. I'm trying to see if there is anything that I can take as a common factor, or how can I make my problem easier. I don't see anything yet. I don't need to take x as a common factor yet. What I can do, I'll do all these times that, and then all these times that, and then all these times that, and then all these times that. Okay, so this will be 2 over 3x multiplied by 6x minus 2 over 3x multiplied by y minus 3 over 2x multiplied by 4x. Now we need to be careful here. Negative here and negative will make positive, so it's going to be positive 3 over 2x multiplied by 4 over 9y. Now, can we simplify? Yes, we can, because here the denominators are 1. Okay, so now we can simplify. You know that 3 and 6, because 3 gets into 6 twice, so 2 is there. And then what else can I simplify? Here's a product also. 2 gets into 2 twice, so 2 is there. And then 2 gets into 2 also twice there. And then 3 gets into 9 twice. So this will be 2x times 2x. That makes 4x squared. 4x squared minus 2 over 3xy minus now we have like 3x times 2x. That makes negative 6x squared. And then over here I left with x times, okay, even even these 2y, 2 and 2 at the denominator here, these also be simplified. So we're left with x times y is equal to xy. So plus xy. Now, can we combine like terms? We can see that 4x squared and negative 6x squared, these can be combined. That makes negative 2x squared. And then negative 2xy and xy, they also like terms. We can combine them. If you do that, you're going to get negative a third xy. Can you prove it to me? Okay, you prove it to me. Or I'll prove it to you. Let me prove it to you. I said negative, I meant positive there. You can do 2 over 3, cover the xy, okay? Because here the coefficient is just 1, okay? So cover the xy, so you have like negative 2 over 3 plus 1. Now, to work out this, you must make 1 is like 1 over 1, so you need to make the denominator common. So we times here by 3, we times there also by 3, okay? And then this is going to be like negative 2 over 3 plus 3 over 3, okay? Now that the denominator are common, we can just add the numerator. Negative 2 plus 3 is 1, so 1 over 3. So, and then I can place my xy here, my xy. So the coefficient makes 1 over 3, okay? Thank you. Okay. Oops, hold on a second. I think I made a mistake. Yes, I made a mistake over here. I want to simplify. Let me just remove all this simplification here. Let me take it off. I think I made a mistake here. Yes. I simplify 2 with 4, and then we got 2 there, left with 2, and then 3 with, oh yes, it's 3 there. So this makes 2 over 3. So it was positive 2 over 3. So this is a positive 2 over 3. Now, negative 2 over 3x and positive 2 over 3x, those also simplify, okay? Because positive and negative. And then the answer will be actually 2x, negative 2x squared, okay? I'm just gonna leave this one for extra information. I mean, how to add a fraction. But the answer here will be negative 2x squared. Next question will be a question 6. We have this a minus 2b plus 3 and a plus 2b plus 3. Good. I'll write the question here. 6. We have a minus 2b plus 3 factor of a plus 2b plus 3. Now, to solve this, we could also expand, as I said, but it's not going to really be the smarter way of solving this. I prefer to transform this way. I write here, write it as a plus 3 minus 2b. I prefer to write it like that. Or maybe, okay, hold on. I'll write it this way. I'll write it like a plus 3 minus 2b, which is basically the same thing as this one. This is the same thing as that, bracket. I just move the negative 2b over and then move the 3. I just swap these two. Okay? So I have like a plus 3, I'll group them. Okay? Minus 2b. Okay, let's just take this one out. Okay, and I do the same thing there also. A plus 3 and then plus 2b. I also do the same thing there. These two are also the same thing. I just move 3 closer to A, and then B, just interchange the places. Now, note it is the form, this is the form A minus B times A plus B. Okay, this is actually product A minus B times A plus B. The product that leads to a difference of 2 squared, A squared minus B squared. So over here, we can just see A plus 3 squared, okay, minus 2B squared, okay, and then A plus 3 squared, according to our formula, when we said A plus B to the power of 2, this is just equal to A squared plus 2AB plus B squared. We can work this out. Our A is A and B is 3. So it's going to be like A squared plus 2AB. So 2 times 3 times, 2 times A times 3 minus, plus B squared. So 3 squared minus 4, 2B to the power of 2 is just 4B squared. And this is going to be equal to A squared plus 6AB plus 9 minus 4B squared. That's the answer. Okay. Now question 7 will be okay, this, let's do it. Okay, do you want me to recap? What I did here, I just moved 3 closer so I can form a difference of 2 squares, and then from here calculations become easier. Okay. Now we're going to do question 7. Let's see question 7. Question 7. Let's see. Question 7 is, where is it? Okay, question 7 is over there. This one. Write the question here. This will be 7 will be 3x squared minus 4y cubed, okay, raised to the power of 2 minus x squared excuse me, plus 2y cubed, and then negative x squared plus 2y cubed. Now, this is, when I look at this one, if I look at what is on the right, on the left here, it is a perfect square because it is raised to the power of 2. Okay, there is a property that we learn about perfect squared. We did say that I'll write the property here when we have like A minus B to the power of 2. This is equal to what? Equal to A squared minus 2AB plus B squared. Okay, and when I look at this also, this part also, we can make a difference of 2 squares here because we have like x squared plus 2y cubed and then negative x squared plus 2y cubed. There are different ways of making difference of 2 squares. Like if, for instance, I interchange the sides, over here I write like 2y cubed plus x squared, and then over here I swap also the sides. If I switch the sides, it's gonna be 2y cubed minus x squared. Okay, now we have a difference of 2 squares over here. So a product that leads, a product that leads to a difference of 2 squares. So if you have A plus B times A minus B, this is equal to A squared minus B squared. Okay, so we can apply those formulas to solve the problem. For the first one, I'll write like a squared, okay, minus 2ab plus b squared. For the second one, it's minus careful here, I'm gonna use square bracket because we need to be careful whenever we have a negative sign in front of the brackets. Okay, I'm gonna use square brackets here, and then here this part I'm gonna have like a squared minus b squared. Okay, then a was like 3x squared. A is 3x squared minus 2a, so 3x squared, and then b is 4x cubed, 4y cubed plus 4y cubed. There, I just applied this formula here for the perfect squared, and then for the difference of two squares is over here, and then this I will say it's 2y cubed to the power of 2 minus x squared to the power of 2. Now let's work it out. Remember the law of exponent says a to the m raised to the power of n, this is equal to a to the m times n. Okay, so over here we will times the exponents, okay, and then there also we times exponents, we times. So this will be like not 6 but 9x to the power of 4, okay, because the power of 2, okay, let me remind also when we like a times b to the power of m, this is like a to the m times b to the m. Okay, so this power of 2 is for both 3 and x squared. 2 on 3 makes 9, 2 on x squared makes x to the power of 4. Okay, minus over here we can just do 2 times 3 times 4, that makes 24. Okay, minus 24 x squared y cubed. Okay, plus that makes the power of 2 here is for 4, is also for y cubed. That makes 16y to the power of 6 minus let me see, use bracket there, and that makes here the power of 2 is for 2 and also for y cubed. That makes 4y to the power of 6 minus x to the power of 4, close bracket. Okay, is there anything to simplify? Let's see. I don't see anything yet, but now let's continue solving this. That makes like 9x to the 4 minus 24x squared y cubed, okay, plus 16y to the 6 minus 4y to the power of 6 plus x to the power of 4, okay, because when we drop the brackets, okay, it changed the signs of everything within the brackets. Okay, so we can underline like terms. We have 9x4, that makes 10x to the power of 4, and then minus 24x squared y to the power of 3 plus 16y to the 6 minus 4y to the 6 makes positive 12y to the 6, okay, because they are like terms. Okay, thank you. Now we can do question 8. Okay, here it is. Question 8 is there. I wanna say 8 is over there, and then it's 5a minus 2b to the power of 3. Okay, there's a formula for that, it's a special formula, but in short, I will prefer to say, this is like 5a minus 2b, okay, times 5a minus 2b, and then times 5a minus 2b, okay, or we can say 5a minus 2b multiplied by 5a minus 2b squared, okay, because all this makes 5a minus 2b raised to the power of 2. Now we can apply the special formula for the square. So we said a minus b to the power of 2 equal to a squared minus 2ab plus b squared. And then we're going to times with, so it's going to be like 5a minus 2b, okay? Times, I use square brackets here. Then I can say, so a squared minus 2ab plus b squared, okay? Now I can substitute. My a is 5a, okay? My b is a again, because minus 2a, a again, and b is 2b, and then plus b squared is 2b squared. So this will make 5a minus 2b, okay? And then that makes what? 25a squared minus 20 ab, 2 times 5 times 2, okay? And then a times b plus 4b squared. Okay, over there I was already put in my round bracket back. Now we will times, and 5a times each of the terms here, and then negative 2ab times each of the term there. And then this will be 5a times 25 makes 125a cubed. Okay, 5a times 20 negative 20ab, that makes negative 100 a squared b. 5a times 4b squared, that makes positive 20 ab squared. Okay, and then negative 2b times 25ab a squared, that makes negative 50 a squared b. Negative 2b times negative 20ab, that will make positive 40ab squared, and then negative 2b times 4b squared, that makes negative 8b to the power of 3. Then are there like terms to simplify? Let's see. Terms that end with a cubed, we don't see. Term that end with a squared b, we see that we have like this and that. They end with a squared b. We can combine them, so it's like 125a cubed minus 150, okay? A squared b, because negative 100 minus 50 makes 150. And then terms that end with ab squared, so we have this one and that one. We can combine the two. That makes positive 60, okay? Positive 20 plus positive 40 plus 40 makes 60 ab squared minus 8b cubed. Okay, and that's the final answer. Okay, thank you. Now we can do question 9. Here it is, question 9. I want to write it over here. Question 9, we do have like 2x to the 4 plus 3x to the 4 all to the 3 all over 2x to the 4 times 3x to the 4 raised to the power of 2. Okay, so what's this equal to? Now we can see that the numerator, we have like terms, so we can combine them. We can do 2 plus 3, that makes 5 x to the power of 4 raised to the power of 3. Okay, and the denominator, it's a product, so we can do 2 times 3, which is 6. And then x to the power of 4 times x to the power of 4 makes x to the power of 8, okay? Because when we times fraction, some basis we add exponents. It's going to be this to the power of 2. Now over there, it will be like, let me write the formulas here. say a to the m times a to the n equal to a to the m plus n. This is what applied at the denominator here. And then I need to apply this other formula, a b to the m. This is equal to a to the m times b to the m. So this exponent 3 here is for both 5 and x to the power 4, okay? So for 5 to the 3 equal to 125. And then another formula we know is like a to the m or to the n equal to a to the m multiplied by n. So x to the 4 to the power of 3 again, this makes x to the 12, x to the 12 all over 6 squared. So if I apply this formula, so this power is for the 2 and also for the x to the 8, that makes 6. 6 squared is 36. And then 8 to the power of x to the power of 8 to the power of 2 makes x to the power of 16. Now, we can simplify this further. We can just write 125 over 36, okay? And then multiply by, okay, we can simplify them by 3 because 125 is a multiple of 3. Is it? No, it's not. It's still, no, it's not a multiple of 3, so I'll leave it like 125 over 36, and then x to the power of 12 minus 16. Okay, actually, because look here, the highest, the exponent with the basis with the highest exponent is at the denominator. Instead of moving 16 on top, I rather move 12 at the denominator. So this is like, it's going to be written as 125 over 36 x to the 16 minus 12. Okay, so this makes 125 over 36 x to the power of 4. So that's the answer here. Okay. Okay. Okay, that was the last question, question E. Thank you. Well, we have another question here. That's question F. We're going to do question 1. Right here, 1. We have like 3x squared minus 5x. Okay, minus 12. So we are going to, the question says factorize the following. So now, okay, this is a case where we have a coefficient in front of a coefficient different than 1 in front of x squared. So in cases like this, what we do, we're going to times that with the constant term 12. So I'm gonna write here 12 there, and then it's negative 12. 3 times negative 12. Excuse me. 3 times negative 12 we make negative 36. And then the factors, we're going to list all the factors of 36, preferably in ascending order. So there will be like 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now we are going to say look for the only one couple that will make a sum equal to the coefficient of the middle term, -5. Okay, now let's see. We see that we can get -5 only if we have like a positive 4 and a -9, because 4 minus 9 makes -5. Okay, and then 4 times -9 makes -36 here. So we're going to split the 3 terms into 4 terms. So that will be like 3x squared. Instead of saying minus 5x, we're going to write plus 4x minus 9x, okay? And then minus 12, okay? Now that we have 4 terms, you can factorize this by grouping. You can group pairs of 2 and the other pairs of 2. So now for the first 2, this term and that term, we can take x as the common factor, and then this will be in the bracket. I can write here 3x plus 4, and then for the last two also, I can take this and that. I can take -3 for common factor, so take -3 out for common factor, and then there should be 3x plus 4. Okay. Now that we do have this and this common, okay, note that those two must be common. If they're not common, it means either we selected the wrong factors over here, or we didn't factorize properly, okay, from line 2. Now, because they're common, we can just take 3x plus 4 common factor. So this will be like 3x plus 4 factor of x minus 3. Now we don't factorize this. Okay, question 2. We have 3x squared minus 9x minus 12 minus 12. Okay. Over here, what we can do, we note that when I look at the question, each term here is a multiple of 3. So we can take 3 as the common factor because it is the common factor. I can take 3 out as the common factor. And within the bracket, I'm left with x squared minus 3x and then minus 4. Now, over here, I can look at the last term. Okay, I can write, because the coefficients of x is just 1. Okay, we don't see any number in front of x, so I can just write x in the bracket like this, in the bracket like that. Now I'm going to consider the last term, -4. Okay, I'm gonna write here -4. The factors of 4 are 1 and 4, 2 and 2. Now, if I ask myself, how can I get from the factors of 4 a sum that will make the coefficient of the middle term -3? How can I get it? Only if I have a +4 and a +1 and -4 there. So those are the values I can place in here, +1 and -4. Okay, we do this. We don't when it's when the coefficient is just, when we don't see any number in front of the x squared, we don't need to split it into 4 terms. We can just select what factors to place in here. Okay. Now we can do question 3. Let's move. Question 3 says 12 minus 6x minus 3x squared. So in this case, I think it is better to first rearrange this, okay, in the standard form of quadratic trinomial. So this can be written as -3x squared minus 6x and then plus 12. Okay. Now, again, we can note that each term of this expression is a multiple of 3. To say it better, I can say multiple of -3. So I can take -3 out as the common factor, because it is the common factor, and then there should be like x squared plus 6x, and then, no, not plus 6x, but plus 2x, plus 2x minus 4. Okay. If you're unsure, you can try -3 times that makes -3x squared, -3 times that makes -6x, -3 times -4 makes +12. Now, over here, the last term is -4, so I can write somewhere there -4, and then start listing the factors of -4. They are just 1 and 4, and then 2 and 2. Now that there is no coefficients in front of the x squared, okay, we can just write over here -3 open brackets x close brackets open brackets x close bracket. Now I need to find the values that I can place in here. Now let's see which couple here can make a sum equal to the coefficients of the middle term +2. Now let's see. With 1 and 4, we cannot get +2. Neither will 2 and 2 make +2. So this means this equation will be, we stop here when we factorize this equation. This is the final answer. Okay, so we don't need to. We cannot factorize. This trinomial is we call it like prime equations when we cannot factorize. Okay. Okay. Now we're going to do the next question is question 4. We have x cubed minus 64x. All right, here question 4. We have x cubed minus 64x. So over here, we do have x cubed and then one x there, meaning we can take x for the x for the common factor. Okay, can take x for the common factor here because there are 3 of them here and then 1 here. So this will be x squared minus 64. Okay, and now 64 is a square number. It is a square of 8. So this can be written as 8 squared. And now we can over here apply the difference of 2 squares property. So we know that a squared minus b squared equal to a minus b and then a plus b. Okay, so this will be x open bracket x minus 8 and then x plus 8. Now we can say we factorize this fully. 5. Question 5, let's see what they said. X cubed minus 64. Okay, so let's see. We have x cubed minus 64. It is important to note that 64 is also a cube number. It's a square of 8, but it is a cube of 4. So it's going to be like x cubed minus 4 cubed. Okay. Now we have like what we call the difference of 2 cubed. Remember, we say the property says like a cubed minus b cubed. This is equal to a minus b. Okay, in the bracket like that. Open brackets a squared plus ab plus b squared. Okay, so we can apply this property to answer this question. We can say this will be like x minus 4. Okay, because over here a is like x and then b is like 4. So we can say ax minus 4, open bracket, a squared, so x squared, plus ab, so plus 4x. Be careful here, 4, b is not negative 4, just 4, okay? Plus 4x, and then plus b squared, which is 4 squared, so 16. So this is the equation factorized. Now, note that this part cannot be broken down. This is always a prime equation, a prime expression. We cannot factorize this. A prime quadratic expression. So we cannot factorize this. Thank you. And then the question 6 says x squared minus 64. You have x squared minus 64. Over here, we can also solve this by difference of 2 squares, because you know this is like x squared minus 8 squared, because 64 is 8 squared. So this will be applying the difference of 2 squares property that we listed over here. Okay, it's actually basically this part. This will be x minus 8 and then x plus 8. Okay. We can also do the next question will be question 7, 4x squared minus 100. Okay. 4x squared minus 100. We can do it over here. In this case, we can first yeah, we can do that in 2 different ways. Note that we can take 4 as the common factor here. Okay, 4, because 4 gets into 4 and also to 100. Okay, and then this will be like x squared minus 25. I think this is the best way. And then we can have like 4. And then there we have again another difference of 2 squares. So it's going to be like 4x minus, it's going to be like that x squared minus 5 squared. And which is 4 equal to x minus 5. And then x plus 5. Okay. Or someone else may say we can, 4 is also a square number. So we can write it like 2 squared. So we have like 2 squared, x squared minus 100. 100 is also a square number. It's a square of 10. So it's going to be like 10 squared. Okay. Now over here, we can apply the difference of 2 squares. Okay. So this will be, okay, before even I do that, the fact that the power here are common, we can write 2. We can write it like 2x to the power of 2, like this. Okay. And then we have that minus 10 to the power of 2. Now over here, we have now the difference of 2 squares where we can say 2x minus 10 and then 2x minus 10. The thing is, if we do this way, we still have more to do, okay? Because 2 and 10 have common factors, both sides. So we can take 2 here for common factor and then 2 there also for common factor. And that's x minus 5 and then x minus 5. And then 2 times 2 here can make 4. And then we have x minus 5 and x minus 5. This is another way, but I prefer to work out to do this way. So the best way usually is when you work out expressions, you simplify expressions, better simplify from the first line, okay? Here we can see that 4 gets into 100. We could have just take, 4 out as the highest common factor. Now the next question will be, we can do question 8. Question 8 says 4x squared minus 100x, okay? So let's just move this. 4x squared minus 100x. In this case, we can take, if we decide to take we can take the first, the common factor between the two terms. We can see it's 4x, okay? 4x is the highest common factor, and then we're left with x minus 25. And then here we can do much because we cannot simplify further. That's all. Okay. Now we can do question 9. The question 9 was x squared plus 64. Now what to do here? Now this is where I need to draw attention. Nota bene, NB. We call nota bene in Latin. This means I was saying there is no property for the sum of 2 squares, okay? This is still a squared plus b squared. So over here, the answer will remain x squared plus 64. We don't factorize this. There's no formula for that, no property, no nothing. So it remains this way, okay? And then question 10 was x squared open bracket x minus 3 minus 4 open bracket x minus 3. Now over here we notice the highest common factor will be x minus 3 in the bracket like that. So we can do we can take it as the common factor x minus 3 and then x squared minus 4, and then we're done factorizing. No, we're not done because we still have more to do. Note here we have 4 is a square number, and then x is also raised to the power of 2, so we can apply the difference of 2 squares there, and this would be x minus 3, and then that's going to be like x minus 2 and then x plus 2. Now we can say we factorize this equation, okay? We also have like question 11, which is similar to question 10. Here we have like x squared x minus 3 and then minus 4 3 minus x, and then factorize this. So I wanted to look at these two. Here we have x minus 3, that's 3 minus x. What can we do here? There is a way we can make it same. If I do x, I can make it x minus 3, but this will change the signs, okay, outside the brackets. So because it's negative, I'll make it positive. Check this out. if at times with a negative, if this negative times in, it's going to be -3, that is -3, and the negative times there is going to be positive x, that's the positive x. So we can switch the side, okay, and then change the sign. Now the equation, the expression will look different but still the same, okay? It's just easier for us to factorize. Now we can take x minus 3 as common factor. We can take common factor will be x minus 3, and then x squared minus 4. Again, we can do x minus 3, and then x minus 2, and then x plus 2. Okay. Apologies, it's wrong over here. It's actually plus. I mean, it's a plus there, and then there's no formula for the sum of two squares, as I was showing here. No formula for that. This will remain the same. Okay. Now we can move on. We can do the next question. Will be question 12. Question 12. Question 12 is given by -x squared plus 64. Okay, so this can be rewritten as 64 minus x squared. So to make it easier for us to factorize, and then 64 is a square of 8, as we said, and then this will be like 8 minus x, and then 8 plus x. Okay. Now we can do question 13. Question 13 was 3x cubed minus x squared plus 6x minus 2. Now to do that, there are 4 terms. Okay, I can factorize by grouping. I can take the first two, and the last two also. I'll group them like that. For the first two, I can take x squared for common factor. For the last two, I can just take +2 for common factor. Now for the first two, if I take x squared for common factor, I'm left with 3x minus 1. And the last two is going to be also 3x minus 1. Now, excuse me, if I take this and that, this will be then 3x minus 1, and then x squared plus 2. That's the factor. And then question 14. Question 14 will be 3x cubed minus x squared minus 6x plus 2. Okay, we can do the same. The same thing here. I can take x squared. Okay, these are the first and the last two. I can take x squared for common factor, and then there I'll take -2 for common factor. Okay, let's see. There, if I take x2, I'm left with 3x minus 1. Okay, there if I take -2, we need to be careful over here. It's -2 that we take out, and that's going to be not -3, but 3x there. And then that's going to be not +2, but -1. Okay, because check this out. -2 times that makes -6x. -2 times -1 makes the +2 that we have there. Again, we have this common. So we can say x squared minus 2, and then 3x minus 1. Here, 2 is not a square number, so we cannot factorize, make the difference of 2 squares. So we stop by there. And then with another question, question 15, what we have, 2 minus 16 x cubed. Okay. Over here, we note that 2 is the highest common factor between the two terms. So we can take 2 out for common factor, and then we'll be left with 1, okay? Not 0, 1, okay? Because sometimes students, like, if you take 2 out, no, because 2 is like 2 times 1, you see? It's like there's an invisible 1 there. So when I take 2 out as a common factor, it's gonna be 1 I left here, 1 in the bracket, minus what? 8. minus 8x to the power of 3. Now check this out. We have like 1. 8 is a cube number, so we can write it like 2 to the power of 3, and then x to the power of 3. Now the fact that the 2 here has same power, this can be written as 1 minus, it's like 2x to the power of 3. Okay, we can just change this to square brackets. Now we can factorize this by using the difference of 2 cubed formula. The property says that if you have like a cubed minus b cubed, this is equal to a minus b, okay, and then a squared plus ab plus b squared. So this would be 1 minus 2x, and then it's going to be 1 squared, so 1 plus ab, so 2x times 1 is just 2x, plus b squared, so plus 2x squared is 4x squared. So that's the answer here. Okay, thank you. Well, we have another question here that's here, simplify. We're going to simplify these questions. I am going to write question 1. Question 1 says 3x squared, excuse me. Question 1 says 3x squared plus 6x all over 6x, okay? Now to solve this, I'm going to look at the common factors. At the numerator, for instance, they have like 3x should be the common factor, okay? And then at the denominator, we have 6x there. And then here, if I take 3x as a common factor, I will left with x plus 2. Now, you know, this 6x at the denominator is like 3x times 2. So we can divide, we can simplify that with that. And then we left with 2 at the denominator. So the answer here will be x plus 2 over 2. Okay. The next question is question 2. As we can see there, question 2, I'm gonna write the question. Question 2, we do have like 3 over 4x minus 2x plus 3 over x, and then minus 17x over 3y. Now, to solve this, you know, we need to, when we look at the denominator, they're not common. Okay, we need to make the denominator common. So to do that, we need to find the highest common, the lowest common multiple. So we must look for the LCM. Okay, the LCM of 4x, x, and 3y. So what should be the common multiple, the LCM of these 3 expressions? Now, if we look at the constants, we have like, it must be 12. 12 is a common multiple, the lowest common multiple, because I do 4 times 3, or the lowest common multiple of 4 and 3 is that. And then we need x also, and then y, because x is over here, x is there, and then y is there. So 12xy is our lowest common multiple. Okay, if you're struggling with this, you must check our videos on the lowest common multiples. Now, how to calculate lowest common multiple. So this is 12xy. Now, in this case, you need to make each denominator equal to 12xy. Now, to get 12xy, I must times the denominator over here by 3y. Okay, but if I do that at the denominator, I must do the same at the numerator to make my equation the same. And then over here, I must times there by 12, and then y. I must do the same. You see, when I times by 12y here, I put parentheses because 12y times everything, or the whole numerator here. And then there, I must times by 4x. I'll times it by 4x, I'll times by 4x there. Now, the fraction will become then 9, because that makes 9y over 12xy, okay, minus 12y times 2 makes 24y xy. 12y times 2x makes 24xy plus 36y all over 12xy, and then minus 68x squared over 12xy. Okay, now that the denominator are common, okay, we have like 12xy, we can now combine the numerator, so we can just write 9y minus the negative sign here is the negative sign for all the terms at the numerator. Okay, so this makes negative 24xy, and then no longer positive 36, but negative 36xy, and then negative 68x squared all over 12xy. Okay, that was question 2. Now we can also do question 3. Let's see, question 3 is expressed by this, and then I'm gonna reproduce it here. Question 3 says 3x minus minus x cubed minus 2 over 4x squared plus 1 over 12x. Now, when we don't see any denominator, understand that it is 1. Okay, so over here we will do we can write it as we need to do the same thing. We need to find the LCM. Okay, the LCM of 1, 4x squared, and 12x. Now, the lowest common multiple, we can see that 12 is a multiple of both 1 and 4. I mean of all 1, 4, and 12 itself. Okay. Now, and then, so I will take 12 for the LCM. Now I look again. X squared is also a multiple of 1 because x squared divided by 1 is x squared. X squared is a multiple of itself. It is also a multiple of x because x squared divided by x, it's x. So I'll say 12x squared is the LCM. Now I need to make the denominator all like 12x squared. So I'll times here by 12x squared because it was 1. I'll times also the denominator by 12x squared. The denominator here is 4x squared. To make it 12x squared, I must times by 3. Because if I times by 3, it becomes 12x squared. So I times also there by 3, I'll put brackets. And then over here, it's already 12x. So to make it 12x squared, I'll times here by x. And there, I must also times by x to make my fraction even. Now let's work it out. 3x times 12x squared makes 36x squared over 36x cubed, okay? Okay, over 12x squared minus 3 times x cubed makes 3x cubed minus 6 all over 12x squared minus x over 12x squared. Now that the denominator are common, okay, we can then combine the numerator. That makes 36x cubed minus 3x cubed, and then that makes plus 6, and then minus, minus x all over 12x squared. Now, is there any lactam to simplify? We can see that we have like 36x cubed and then 3x cubed. We can combine those two, they're lactams. And then that would be 33x cubed, okay, minus x plus 6 if I want to write it in that in ascending order of exponents. So that's 12x squared. Okay. Oh, okay. Over here, it was a positive, it was plus, and then I forgot up to plus over here. That's a plus, and that's a plus also. Okay. Now, the answer is correct. Now we can do question 4. Question 4, let's see. Question 4 is that one. 4, right here. We have like 4x to the power of 4 minus 8x squared all over 8x cubed. This is equal to what? So we can take 4 out as a common factor. Not just 4, but we can take 4x squared for the common factor. And then the denominator is just 8x cubed. And then if I take 4x squared as a common factor, I'm left with x squared there minus 2. Okay, because 4x squared is out. If we times, if we times back, we're gonna get 4x to the power of 4, and then that's gonna be 8 negative 8x squared. Now that we do that, we can simplify. You know, this 8 here, the denominator is like 4x squared multiplied by 2x. Okay, so we can simplify this with that. Okay, when we simplify, we're left with 2x. Okay, or someone could just say 4 and 8 cross, and then say x to the power of 2 and x to the power of 3, and then we left with that, and then this will be x squared minus 2 over 2x. So that's the final answer. Okay. Now question 5 will be 2x minus 3 plus 4x squared all over 2x all to the power of 2. So to solve this, we can, I think it's going to be useful if we first work out the fraction. Work out what is within the parentheses. Okay, understand that's over here, the denominator is just 1. So if I need to find the LCM of 1 and 2x, is just 2x. So over here I must times by 2x, and there are times also there by 2x. Okay, so this will be 4x squared over 2x minus 3 plus 4x squared over 2x, okay, to the power of 2. Now that minus, that's going to be like 4x squared. Let's combine the fractions, minus 3, and then the negative sign here, we change the signs of everything. The numerator there, it's going to be negative 3, and then negative 4x squared all over 2x to the power of 2. Now I can do it here. 4x squared and negative 4x squared falls, and then we have left with 3 over 2x to the power of 2, and then that makes 9 over 4x squared. Okay, that's the answer for question 5. Now we can do question 6. Question 6, just move it like that. The question was 3 plus 2x plus 4 over x minus 2 plus x minus 4 over 2x minus x squared. Okay. Now, to solve this, again, we need to make the denominator common. But before we do, let's just factorize the denominator here. So it's like 3 over 3. It's like 3 over 1. Okay, when you don't see any denominator, and then plus 2x plus 4 over x minus 2. You understand why I write this way? Okay, you will understand now. and then plus at the denominator here, you know that we can factorize because they have like x, the common factor. So I can take x out as a common factor. And then there we will have like 2 minus x, okay? Under x minus 4. Okay, now I think I can just move my 1 over there. Okay, then over here I can write 3 over, we can now notice that here we have 1 and then x minus 2, and then this is x open bracket 2 minus x. Is not exactly the same as this. Okay, they're not exactly the same. So what can we do? If I wanna make them the same, I can just switch the values of x and 2 here and then change the signs. Okay, so it will be like this one there, this one there, plus 2x plus 4 over x minus 2. And then over here, the positive sign will become negative if I do this x factor of x minus 2. Okay, if I switch the signs, if I switch the sides of the terms 2 and if I should switch 2 and x, so all under x minus 4. Now check this out. The negative sign affects, because if I times negative x by you know, over here, for instance, I'm just trying to explain it. We did quite a lot of work on this in the previous videos, still in this series. You know, I want to prove why these two are equivalent. If you times here, you're gonna get 2x, and then you times there, you're gonna get negative x squared. But if you times here, you get positive x squared and then negative 2x. But with the negative sign here, it will make it again a negative x squared and positive 2x as it is here. Okay, so now you notice that the LCM, I write it here, the LCM of 1, x minus 2, and x open bracket x minus 2 is just this one, x open bracket x minus 2, because this divides 1. Okay, it divides also x minus 2. It's gonna be x, and then it divides itself. So the denominator here must times it by x open bracket x minus 2. So if I do that, I must also times the numerator by x open bracket x minus 2. And then over here, I must times it by x, and then that one will remain the same because it was it is also the LCM. Then this will be, if I times 3 times x is 3x, 3x times x makes 3x squared minus 6x all over x open bracket x minus 2 plus 2x. Okay, I'm combining, I prefer to do it now. I just combine like terms. I mean combine the numerator, because we have now that we have a common denominator, we can just combine the numerator. So this makes 3x squared minus 6x plus 2x plus 4. This negative sign will affect the numerator. It's going to be like negative x and then positive 4, okay, all over x bracket x minus 2. Now, any like terms, the term that's end with x squared, we have just 3x squared, we don't have more. And the terms that end with negative 6, with x, you have a negative 6x, positive 2x, and negative x. So these together makes negative 5x. So negative 5x plus 4 over x brackets x minus 2 brackets. Okay, that was question 6. Now we can also do question 7. 7 is given by 2 minus x raised to the power of 3 all over x cubed minus 8. So how can we do that? I prefer to factorize the denominator. You know, the denominator, this reminds us the difference of two cubed. Why? Because it can be written as the denominator can be, this is x cubed, and then 8 is a cube number. It's like 2 to the power 3. So here we have the difference of 2 cubed. So the formula says if you have like a cubed minus b cubed, this is equal to what? This is equal to a minus b, and then a squared plus ab plus b squared. Okay, so this is the method we're going to apply here. I am going to write x minus 2, okay, open brackets, x squared plus ab. A is like x and then b is 2, so x times 2 makes 2x, and then plus b squared is b is 2, so 2 squared is 4. So it's gonna be like that, all under 2 minus x to the power of 3. Now 2 minus x to the power of 3 is also like 2 minus x times 2 minus x to the power of 2. Okay, then we see that the two here are similar. We can simplify, but this is 2 minus x, this is x minus 2. There's one thing I can do. I can switch the sides of these two and then put a negative sign there. Okay, so this can be written as negative x minus 2 and then x plus 2, excuse me, and then 2 minus x to the power of 2 all over I'm gonna make it this way. Let's start with the denominator. So we have like x minus 2 and then x squared plus 2x plus 4. Okay, and then at the numerator, then I'll put a negative sign there, put a negative sign over here, and then I will switch the term within the brackets. Okay, it becomes x minus 2 and then 2 minus x raised to the power of 2. Then we can simplify this and that. So the answer will be x squared plus 2x plus 4 under 2 minus x squared. So this we cannot simplify this. This cannot be simplified. Okay, so we can leave our answer like this. I misplaced the power of 2. Power of 2 is outside the bracket. Okay, that was question 7. Now we can do question 8. Question 8 says x squared minus 5x plus 6 under 3x minus 1 minus x minus 3 to the power of 2 under x. Okay, we need to find the LCM. So to do that, let's first see if we can factorize this trinomial, the denominator over here, and then this can be written as, we can write x there in the brackets, close brackets, x there, open brackets, and close brackets, under 3x minus 1. There we have a number, the constant term is 6, is positive 6. The factors of 6 are 1 and 6, 2 and 3. If you need to get a negative 5, this is possible if you have a negative 2 and negative 3. I know also if you have a positive 1 and negative 6, will make a negative 5. But the product here will not be a positive 6 like we have here. The product will be a negative 6. So it cannot be the first couple, but the second couple, -2 and -3. So over here, I place -2 and -3. Then it's minus minus x minus 3 to the power of 2 under x. Now we need to find then the LCM of x minus 2, x minus 3, and the x minus 3 to the power of 2 is also we can also factorize that. That's also x minus 3 and x minus 3. Okay? So over here we can write it like it's like x minus 3 and x minus 3. Now to make the common factor, the denominator over here, we can make it like this: x minus 2, x minus 3. I need to put another x minus 3 there. Because the LCM, as I was saying, the LCM will be x minus 2. We're going to take x minus 2. We're going to take x minus 3. It is here, it is there also, but we have another one now. Okay, so this should be the LCM of these expressions. So there, by the numerator, we have like 3x minus 1. I must also times that part by x minus 3. Okay, I can insist if you have trouble to find the LCM, we have like other videos on LCM. Okay, or you can send us a message and says that you want some videos on LCM, because I cannot really explain that here. This is from previous grade. Okay, so there you're gonna do x minus 3, x minus 3, and then I need to put x minus 2 there to make the denominator common. So the numerator, which was consist of x only, will also be multiplied by x minus 2. Okay. Now that we have denominator common, okay, you notice that sorry, this part here is the same as that one. We can now combine like terms. We can combine like terms. That makes 3x times x, 3x times -3. So 3x times x makes 3x squared, times -3 makes -3x, and then 1 times x makes -x, 1 times -3 makes +3. And then over there, -x times x makes -x squared, and negative times -x times, because this sign here affects everything there. Okay, so it becomes -x times -2 makes +2x over the denominator x minus 2, x minus 3, and then x minus 3. Now, like terms, we can combine them. We can see we can combine x squared, 3x squared with -x squared. That makes 2x squared. 2x squared. Okay. And then we can also take -3x, -x, +2x. All this makes -2x. -2x, and then we have left with the constant term +3 all over x minus 2, x minus 3, and then x minus 3. I can also put squared here because we already factorized. These two makes x minus 3, the power of 2. Okay, this is just that. Okay. Oh, be careful here. I think 3x times x makes 3x squared, and 3x times negative 3, that was negative 9. I made a mistake here. Negative 9. That's negative 9. And then negative 9x minus x plus 2x here will be negative 8. That makes negative 8 because negative 9x minus x makes negative 10x. Negative 10x plus 2x makes negative 8x. So over here it's negative 8x. Yes, that was question 8. Well, now we can do question 9. Question 9 says x to the power of 4 minus 16 over 16x divided by 4x squared plus 16 over 4x squared. Now, when I look at the first fraction, I can notice that we have kind of a difference of 2 squares here because x to the power of 4 and then can be written as it can be written as x to the power of 2 to the power of 2, okay, minus, and then 16 is also like a 4 to the power of 2, okay, so over 16x, and then the division signs here can be turned to a multiplication symbol operation, and then when we do that, we must switch the fraction. Okay, the denominator, so the numerator will become denominator. So 4x squared plus 16 there first. Okay, yeah, let's just write plus 16 under 4x squared. Okay, then at the numerator we can apply the difference of 2 squares. Remember the formula says if you have like a squared minus b squared, this is equal to a minus b times a plus b. Okay, so this is what we can apply. The numerator there, it's going to be like x squared minus 4 and then x squared plus 4 all over 16 x multiply by at the denominator we can take 4 out as a common factor. That makes what, x squared plus 4 under 4x squared. Okay, and then you know, when we simplify fraction, we can simplify them across also. X squared plus 4, we have x squared plus 4 there, and then x squared plus 4 there also. See, note that this and this are common, so we can simplify. We can cross out this, cross out that one, and then we can simplify this 4 and this 4. Okay, and then we have left with I write x squared and then times x squared minus 4. I'm referring to that x squared, okay, times that in the bracket, all over 16x. Cannot simplify more, and then that was the last question in this series. Okay, thank you. Please.